All right, we're going to do the lesson on 5.3, logarithmic functions and their graphs. And we are going to just kind of click on through here. All right, so our objectives, we're going to find some common logarithms and natural logarithms, both with and without a calculator. We're going to be able to convert between logarithmic and exponential equations. We're going to change logarithmic bases. We're going to be able to graph logarithmic functions, and we're going to be able to solve problems involving logarithmic functions. All right, so a couple things on notation. I want to be sure that folks know that this f with the -1, so that it looks like this is not the same thing as when we're saying the inverse of these values. It's not moving these from the numerator to the denominator. This is saying it is the inverse function of something. So it'd be like if you have square root of x and then you square it, those two are inverses of one another. That would get you back your original value. So while I recognize the notation is the same, you have to take a look at the context and look at the fact that this is before the x. This is saying it's the inverse function of that. So that's one of the notational things. And I want to make sure we understand about how our exponents and how our logarithmic functions are written. Okay, so here we have a log base 2, and I want to point out that this is the same 2 that's here. All right, and this is our ending result of whatever this exponent was. Here we're saying, well, what is the exponent? Here's my value. Here's my base. What would be the exponent that I need to raise this 2 to in order to get the x? Okay? And so doing the inverse function is pretty straightforward. You plug in your x for your y and your y for your x. So that will give you its opposite. All right? So this gives you your original function, and then by switching them around, you're basically doing this to get your inverse function. Okay. On this one, I want to point out a couple things. First of all, we're starting with our y's. We're starting with the exponent, and we know what our function is. So we're going to go ahead and solve this. Right? So 0, 1, 2, 3, right? Remember that your anytime you raise something to the 0, it's going to give you a 1. And anytime you raise something to the 1, you get the original value, the base, back out of it. All right? When you go to the negatives, it becomes a fraction. Right? So here's what your exponential function is going to look like. And here's your logarithmic function. And they're going to be the same, kind of flipped on an asymptote that kind of runs diagonally through those. All right. So as you can see, here's our original function. And then here's our log of that function. All right, it's really easy to see here where we plotted all of our points that we figured out on the previous table. And one thing I want to point out is this is an asymptote here. This will never ever touch the y equals 0. It approaches it, it gets closer and closer and closer, but it will never touch and it will never cross. So that's something important to know. All right. So again, I was kind of talking about how things can be performed. We've got our exponent here, right? We've talked about the fact that is our exponent here. We have our log base a. Well, that a and this a are the same. And then the x is the value that you would have if you raise that a to whatever that exponent is. So there are a couple constraints, but this is kind of a works all the time deal, right? The interchange between them. And we're going to practice some of that. So a couple things. First of all, your x has to be greater than 0. All right? Otherwise, you don't get a real answer. I won't say that there's no answer, but there's no real answer. And then our a is a positive constant, all right? But it cannot be 1. And the reason it cannot be 1 is because 1 raised to any power is still just plain old 1, right? And I've already started talking about it a little bit. These statements are read as the logarithm or log base a, and I normally drop off that of, but I suppose to be perfectly precise, it should be of x. So the log base a of x. Since I do drop that off anytime you hear me say log base a x, if you're not sure whether I pause there or not, feel free to ask, right? Go ahead and contact me and say, what's happening there? All right. So here we're going to take a look. I've got my log base 10 and I have 10,000. All right. So my 10,000, how many times do I have to multiply 10 by itself? Well, I have 1, 2, 3, 4. It's going to give me a 4. Right? If I were to take 10 and multiply 4 tens together, then I would wind up with that 10,000. Now this one's a little different because we're talking about a value that's less than 1. And if you stop and think about this, this is going to be a 1 over 100, right? Because this is my tenths and here's my 100ths. So this is the same as this, which becomes this, right? This is our answer here. So that becomes 10 to the negative 2. And going on to our next slide, we have our 125 is going to equal 5 to the third, because the log base 5, that's not a 10, so we have to think in terms of that new base. So 5 times 5 is going to get me 25, times another 5 gets me to exponent of 3, right? So we would write this log base 5, that base, 125 equals 3. This next one is a little trippy if you don't know what you're approaching. Remember, here's our base, and here we have 3. Well, 3 is the square root of 9. And if you remember, anytime we have something, and this is understood to be a 2 right there, anytime we have some kind of root, it becomes a fraction, and it's 1 over whatever that root is, right? So in this case, it's going to be a 2, right? So the exponent becomes a 1/2. So log base 9, 3 equals 1/2. Or log base 9, 3. Sorry. So for my log base 6, 1, no matter whatever our base is, with the exception of 0, we can't have a 0 value here. Any number that gives you a 1 is an exponent of 0. All right, and we're going to need to keep that in mind as we go. Same deal here. If I have 5, right, on my log base 5, I have a 1 because my 5 to the first is going to get me a 5. All right, that is important. All right, I am going to just hit this last slide here for a moment. It's basically what I've been pointing out, that log base, whatever the base is, 1 is going to give you a 0 exponent. And anytime you have a log base a, you have a 1. Okay? And then again, I'm just kind of pointing out the base and the exponents